All right, so we are about to start a new unit, and this unit is called Function Arithmetic and Function Transformations. And instead of searching for videos for you and trying to find things that fit, I thought instead that I would make a video for you for the first lesson and see how you liked it. And if it works well, we'll keep doing this and kind of see how it goes. So the first section in our new unit is called Function Arithmetic. And if you think back, I guess arithmetic's kind of an old-fashioned word, but they used to talk about the 3 R's of education: reading, writing, and arithmetic. And if you're paying attention, you'll realize that writing doesn't start with an R either. But arithmetic is kind of an old-fashioned name for mathematics, and they usually think about specifically adding, subtracting, multiplying, dividing, kind of the basics of mathematics when they talk about arithmetic. So when we talk about function arithmetic, we're going to take what we've learned about functions in the last unit, and we're going to start to apply adding, subtracting, multiplying, and dividing to functions using our function notation and kind of see how that goes. The first thing we're going to look at is addition and subtraction. So if we read along with me, it says, suppose f and g are functions, and x is an element common to the domains of f and g. So x is any number that you could plug into f, or you could also plug it into g. It's allowed for both of them. The sum of f and g, which we denote f plus g, is a new function defined by the formula f plus g of x. So this is our notation for saying we're going to add the two functions together. F of x plus g of x. So take the formula for f and add it to the formula for g. And on the next slide, you're going to see some examples as we actually do this. So that's the sum, and then the difference, pretty similar. The difference of f and g is denoted f minus g, and is the function defined by the formula function f minus function g. Take the formula for f, subtract the formula for g. And simplifying, in this case, would just look like collecting like terms and that kind of thing. So if this seems pretty abstract at the moment, hopefully the next slide will make it more concrete. So, for example, I have function f, that is 6x squared minus 2x, and function g, that is 3 minus 1 over x. And I want to find and simplify the expression f minus g of x. So from the previous page, f minus g of x is equal to f of x minus g of x. And we want to substitute in here the formula for f. So up here, the formula for f, 6x squared minus 2x. And the second one, the formula for g, so 3 minus 1 over x. And I'm subtracting those two. So we want to subtract, and I'm going to put it in parentheses, 3 minus 1 over x. Okay, so formula for f, which is written in blue, minus the formula for g, written in red. And then we want to collect any like terms, and in this case, get rid of the parentheses. Because all our terms are different, the x squared has no friends, the x has no friends, the 1 over x, the constant, the only thing we can do is distribute this minus. So the minus will go to the 3, and the minus will also go to the minus 1 over x. So that leaves us with a final answer. So a 6x squared minus 2x minus 3 plus 1 over x. And that's it. That's as simple as it gets. Nothing else to do with it. So if you need to pause your video here, copy down the example, and then we'll try the next, or we'll go on to the next part. Okay, the next part says find the domain for f minus g of x. So the domain is all the numbers in the domain of f that are also in the domain of g. So if we think about first just the domain of f, so the domain of f at x, there are no restrictions, no denominator, no square roots. If you graph it on your calculator, it actually ends up being a parabola that goes to infinity in both directions. So my domain is from negative infinity to infinity for the function f. Now the function g, on the other hand, does have a denominator. So when I'm thinking about the domain of g, I have to remember the denominator is not allowed to equal 0. So x is not allowed to be 0, which means when I'm thinking about the domain of g, I will go from negative infinity up to 0, jump over 0, and go all the way to positive infinity. And if you graph this one on your calculator, you get, these are my x and y axes, you get a function that looks something like this. So you can see it's going to go off to negative infinity in this direction. When it comes to 0, it jumps, and then it goes off to negative or positive infinity in this direction. So the domain for f minus g, we have to combine these two together. Well, f didn't have any restrictions, and g jumped over 0. So that means if we want to be able to go for f minus g, we also have to take this jump over 0 into consideration. So the domain of f minus g are all the elements in f that are also in g. So that would be everything except 0, because 0 is not in g. In other words, f minus g has the same domain as g itself, because f had no restrictions to contribute. So far, so good? All right, one more example on this page before we go on to the next page. And this one says, evaluate f plus g of negative 1. So this time, instead of just thinking in terms of x, we're going to do it with an actual number involved. So thinking about this kind of notation, f plus g of negative 1 would be f of negative 1 plus g of negative 1. Well, f of negative 1, plug a negative 1 in here. So that's 6 times negative 1 squared minus 2 times negative 1. There's f of negative 1. Plus g of negative 1, plug a negative 1 in for x. So that's a 3 minus 1 over negative 1. Simplify that down. So this is going to be 6 plus 2 plus 3 plus 1. And I think if you add that all together, that comes out to be 12. So f plus g of negative 1 is 12. So that is adding functions and subtracting functions. We did one example where we just had an x and we came up with a new formula. And the last example where we actually plugged in a number to both f and g and added the results. Pause the video here if you need to write anything down, then we're going on to the next question. All right, multiplication and division. The product of f and g, which is denoted fg or f dot g, is the function defined by the formula f dot g of x equals f of x times g of x. So again, pretty straightforward. We're making a new formula, a new function called f times g, and we can define that with another letter if we wanted to. We could call it h or m or whatever. And the way our new formula is defined is just by multiplying the two functions f and g together. And the quotient of f and g is denoted f over g, or f slash g, and it's the function defined by the formula f slash g of x. And we're going to divide them, f of x divided by g of x, provided that g of x is not equal to 0. So again, we're thinking about our denominator, and we're saying we've got a new restriction now, because now we're dividing by g, so our new restriction is going to be g is not allowed to equal 0. On the next slide, we'll work through a couple examples. So we've got our same friendly functions f and g, and we're going to find some new functions. So it says find and simplify the expression for f slash g of x. Remember that that's equal to f of x over g of x. So on the top, I'm going to substitute in my formula for our f, which is 6x squared minus 2x. And on the bottom, I'm going to substitute in my formula for g. So my 3 minus 1 over x. And to simplify this expression, I need to get rid of this denominator extra fraction thing. So remember that we get rid of the fraction over a fraction by multiplying top and bottom by your least common denominator. So in this case, that's my 1 over x. So I'm going to multiply the top by x and multiply the bottom by x. And when I do that, I need to distribute. So 6x squared times x will give me 6x cubed. My x times minus 2x will give me minus 2x squared. On the bottom, my x times 3 will give me 3x. And my x times 1 over x will give me x over x, or 1. Now let's see if I can actually simplify this any further. I can factor the top. I have a greatest common factor between 6 and 2, which would factor out a 2. And I have a greatest common factor of x squared, between x cubed and x squared. So if I factor out a 2x squared, if I take a 2x squared out of the 6x cubed, I'm left with a 3 and an x. And if I take a 2x squared out of a 2x squared, I'm left with a 1. So I've got 2x squared times 3x minus 1. And on the bottom, I still have a 3x minus 1. Well, this factor on the top matches my entire denominator, so I can actually simplify this down. This will cancel with this and leave me with a final answer of just 2x squared. So there's my simplified formula. So again, the idea is fairly simple. F slash g is equal to f, the function, divided by g, the function. And I take each of their formulas and substitute them in. And then the rest of that is algebra simplification till we get down to our final answer of 2x squared. Find the domain for f slash g of x. Well, we said these are all the values that are in the domain of f and all the values that are in the domain of g, so it has to be in both of them. And we had a new restriction where g at x, our bottom guy, was not allowed to equal 0. So we know from the previous example already the domain of f was from negative infinity to infinity. And also from the previous example, we know that the domain of g was jumping over 0. So negative infinity up to 0, and from 0 to infinity. So we're going to have to keep those restrictions in mind. And then now we have this new restriction. Not only do we need to care about the domain of g, but all of g together is not allowed to equal 0. So 3 minus 1 over x is not allowed to equal 0. And that comes because there's our denominator for our new function. So we need to solve this for x to figure out what that adds. So if we move this 1 over x to the other side, we've got 3 is not equal to 1 over x. And get this x out of the denominator by multiplying both sides by x. So 3x is not equal to 1. And get x by itself by dividing out the 3. So x is not equal to 1/3. So from this restriction of g at x is not equal to 0, we get now x is not allowed to be 1/3. So to put all those 3 pieces together, this gives us no restrictions, this gives us a jump over 0, and this gives us a jump over 1/3. So my final answer for my domain of my new function would go all the way from -infinity up to 0. Then we're going to go from 0 to 1/3. And from 1/3 to infinity. So far, so good? All right. Last piece of this example. Again, we're going to do one that's an evaluate question, meaning we're actually going to plug in a number. So evaluate f dot g of 2. Well, from our previous slide, hopefully you remember, this is just equal to f of 2 times g of 2. Which means plug a 2 into your function f. So 6 times 2 squared minus 2 times 2. There's my function f. Times, stick a 2 into my function g. 3 minus 1 over 2. And as I simplify that down, this becomes 6 times 4, 24, minus 4, so 20. And this becomes, well, 3 minus a half should be 2.5 or 2.5. And 20 times 2.5 is 50. So f dot g of 2 is 50. Took a moment, pause the video here if you need to write anything down, and then we're going on to the next slide. So when we do function arithmetic, our functions can be defined in terms of equations, like we saw in the previous example, or they can also be defined in terms of graphs or even in terms of tables. So in this case, we're going to define f and g using a graph, and f of x is the blue parabola, and g at x is the red line. Using that, we can evaluate certain values. It's a lot harder to use that kind of a picture to draw a new graph, like we did a new formula, but evaluating values actually isn't that bad. So, find the indicated values, f plus g of 0. So that would be equal to f of 0 plus g of 0. Well, if I go to my graph, I can find f of 0 is my y value when my x value is 0. So here's x equal to 0. So right here on my graph, you can see f of 0 equals 1. So plug in a value of 1 down here. And g of 0 means on my g graph, when x is 0, what's the value of y? So g at 0 is 3. So down here, plus 3. And 1 plus 3 is 4. So f plus g of 0 is 4. Similar idea with multiplication, division, doesn't really matter. I'm going to use the same idea. So f dot g of minus 2 would be f of minus 2 times g of minus 2. Well, f of minus 2 means our y value when f is minus 2. Sorry, when x is minus 2. So come over here, minus 2, right here on my value, on my function f. So f of minus 2 is equal to 1. And just so happens that g of minus 2 is in the same spot. So g of minus 2 is also equal to 1. And 1 times 1 gives me a final answer of 1. So again, this has been function arithmetic, adding, subtracting, multiplying, and dividing functions. Sometimes we find a new function using function arithmetic, or sometimes we evaluate them for certain x values and find a new x value. We also looked at how to find the domain when we create a new function using addition, subtraction, or multiplication and division. And with addition and subtraction, it was as simple as combining the domain of the two functions we started with. And for multiplication and division, we combined the domain of the two functions we started with, and for division, we said the function that's being divided by can't equal to 0, which gave us a new restriction. So then we combined the domains of the two functions we started with plus this new restriction. And last we said functions can be defined by formulas, or they can also be defined by graphs. So we looked at an example of evaluating a function using a graph. Hopefully this has been helpful, and if you have any questions, feel free to message me, email me, set up an appointment, and we can talk via Zoom.